The Milky Way is too large for the human mind to imagine its size, as we cannot compare it to anything everyday. Its diameter is approximately 1 trillion kilometers and contains between 200 billion and 400 billion stars, among which is our star, the Sun, the center of our solar system. With this documentary video, we will try to understand the size by recreating the solar system to scale up to Saturn, since even to Neptune, which is the farthest planet from the Sun. It would take us to a distance of 3.2 kilometers on this scale. Furthermore, the boundary of the solar system is not at the last planet, but rather at the heliopause, which would be 5,292 kilometers in this scale. Starting with the star, the Sun, we must imagine it in 3 dimensions to realize its great volume in relation to the rest of the planet. Its actual diameter is approximately 1,392,000 kilometers. In this representation, it has a diameter of 1 meter. The closest planet is Mercury, at an approximate distance of 58 million kilometers. In scale, it is 41 meters, and we can see how the Sun would look from this planet. The next planet is Venus, which is 77 meters from the Sun on this scale. It should be noted that the representation of the planets will be displayed aligned. So we are seeing the moments when the distances between them in their orbits would be the shortest. At 107 men from the Sun in this scale is the Earth, our planet, quite stable in its rotation line, thanks to the Moon, which is not the case for all planets, although they do rotate in the same direction, except for Venus, which rotates in the opposite direction. The Moon is 28 meters away on this Uranus scale, with a diameter of 2.5 meters, while the Earth is just over 9 meters. It has sometimes been referred to as a biplanetary system, due to its proportions.
Seeing this, we realize that we are insignificant, but when we finish watching the video, it will be indescribable. Next is Mars at a distance of 163 meters. On this scale, its diameter is almost 5 millimeters, half that of Earth. Interestingly, its rotation is 24 hours and 41 minutes, the most similar to Earth, which is 23 hours and 56 minutes. Its complete orbit lasts almost 2 years. Keep in mind that the planets do not orbit on the same imaginary plane. Let's say they have an inclination relative to a plane, with Earth as the reference point. The planet with the greatest inclination is Mercury, with 7 degrees relative to Earth. One of the reasons why Pluto is not considered a planet is its inclination of 17 degrees, in addition to other reasons such as its size. Pluto is classified in the category of dwarf planets, of which 5 have been discovered so far. Their orbits are not perfect circles either. Therefore, the different distances between the planets will depend on the moment and also on these factors among others. From Mars to Jupiter, there is a real distance of 550 million kilometers. On our scale, about 395 meters, that we will pass quickly. Even so, one can imagine and be aware of how small we are. And after this great leap of 395 men from Mars, we arrive at Jupiter, which is 559 meters from the Sun on this scale, and is the largest of the planets, measuring 10 centimeters in diameter on this scale. The complete orbit around the Sun lasts nearly 12 years. It also highlights its faster rotation than any other planet in the solar system, that is, in less than 10 hours. This planet is a massive gaseous body. The solid surface is not well defined. As a curiosity, It is so far away that the sun looks very small. The light takes 43 minutes to arrive. Moreover, its size causes the planet itself to radiate more heat than it receives from the scarce sunlight. Nowadays, there is a wealth of detailed information available on the internet, and most importantly, it is updated to satisfy our curiosity and to complement this video. We just made another jump, also very large, to Saturn, of 466 mm, and we will be 1 kilometer from the Sun on our scale. The actual distance is 1,427 million kilometers. Saturn is also gaseous, and its most characteristic feature is its bright rings, which are visible from our planet and flattened at the poles. An interesting fact is its specific density of 690 km3, being the only planet in the solar system with a density lower than water, as it is composed of 90% hydrogen and 5% helium. The rotation period is uncertain since it does not have a solid surface. Thanks to the Voyager probe, it was considered to be just over 10 hours, but these vary over time. The only solid part is its core. And this concludes the representation, as Uranus would be 1 kilometer from Saturn, which means it would be just over 2 kilometers from the Sun, making it unfeasible to represent. But we would be talking about double the distance from where we are at Saturn. And the last planet, Neptune, is 3.2 kilometers from the Sun in our scale. The next set of bodies is the Kuiper belt, which would be at a maximum distance of 10 kilometers from the Sun on our scale. Next, the scattered disk would be found, and we would encounter more accumulations up to the Oort cloud at a distance from the Sun, ranging from 307 kilometers to 1078 kilometers on our scale. The last remaining part of the solar system is the heliopause, located 5,392 kilometers from the Sun on our scale. After an interstellar void, if we traverse it, we could reach other systems in our galaxy. The closest star is Alpha Centauri, which is 4.22 light years away, or 40 trillion kilometers on our scale. It would be approximately a whopping 26,000 kilometers